Morning dear students, welcome back to online classes. In today's class, we are continuing the methods of preparation of amines, that is Gabriel thalamide synthesis. Already we have finished 4 different methods, that is reduction of nitro compounds by reducing nitro compound. For example, nitrobenzene, when it is reduced by using reducing agent, that is metals in acidic medium, will get aniline or benzenamine. That is the first method. Second method, by the reduction of nitriles. By the reduction of what? Nitriles. What are nitriles? Nitriles are the organic compounds which contain CN functional group. CN means there is a triple bond between carbon and nitrogen. So we can reduce that nitrile by adding reducing agent, that is lithium aluminum hydride, or we can also pass hydrogen gas in the presence of catalyst like either palladium, nickel or platinum. So by reducing nitrile also we can get out, we can get a primary amine. That is the second method. Third method, that is by the reduction of amides. Amides means amides are the organic compounds obtained from carboxylic acid. Reaction of carboxylic acid with ammonia gives you an amide, acid amide, and that amide when it is reduced by using lithium aluminum hydride, again will get a primary amine. Last fourth one which we studied in the last class, that is by ammonolysis. Ammonolysis of alkyl halides. Ammonolysis means cleavage of carbon halogen bond of an alkyl halide by adding ammonia, by adding ammonia. That process it is called as ammonolysis. So in that method we are heating an alkyl halide with ammonia at a temperature of 373 Kelvin in a sealed tube. What happens is successively hydrogen atoms gets replaced, that is hydrogen atoms of ammonia gets replaced by alkyl groups forming primary amine, secondary amine, tertiary amine, as well as quaternary ammonium salt. So these things we have studied it in the last class. Today we are going to discuss an important method which is used for the preparation of amine, that is Gabriel thalamide synthesis. Gabriel thalamide synthesis, and this method Gabriel thalamide synthesis, it is used only for the preparation of aliphatic primary amine. This method it is used for the preparation of what? Aliphatic primary amine. Now starting compound in this method, that is thalamide. So we are taking thalamide in the reaction Gabriel thalamide synthesis. Now what is this thalamide? See, thalamide, it is an organic compound Thalamide means what? It is an organic compound obtained from a dicarboxylic acid, that is phthalic acid. That is what? That is phthalic acid. So the structure of phthalic acid, it is like this. This is dicarboxylic acid. Name of this dicarboxylic acid, what is this? This is phthalic acid. Phthalic acid. Now this phthalic acid, when it is treated with ammonia, phthalic acid it is acidic in nature, ammonia it is a base, acid-base reaction takes place. Acid-base reaction takes place forming a salt. COOH becomes COONH4. It becomes ammonium salt. This reaction you have already studied it in the last unit, that is carboxylic acid. So this is ammonium salt. Ammonium salt of phthalic acid. What is this? Ammonium salt of phthalic acid. So this ammonium salt of phthalic acid, when it is heated, it loses water molecule. It loses what? Loses water molecule, 2 molecules of water. So after removing water from these two groups, I will get CONH2, CONH2. CONH2 means it is an amide. Name of this amide, it is thalamide. Name of this amide, it is what? It is thalamide. Here I have tried two molecules of ammonia. So it is thalamide. Now this thalamide, I will write it here. It is CONH2. Again it is CONH2. Now this thalamide, it is heated strongly, or I can write on strong heating. This thalamide readily loses ammonia. Readily loses what? Readily loses ammonia, NH2 and H. So when I remove this ammonia, what I will get? I will get CO. Here it is also CO. Remaining thing is NH. It is what? It is NH. Now this is thalamide. What is this? Thalamide. So reaction of phthalic acid with ammonia initially will give you ammonium salt of phthalic acid. Ammonium salt of phthalic acid readily loses water, 2 molecules of water on heating, giving what? Giving thalamide. Thalamide on further heating or on strong heating loses ammonia, forming thalamide. Forming what? Thalamide. Now this is the compound which is required for Gabriel thalamide synthesis. So I have tried the structure of thalamide. Thalamide, it is the compound which is required for the preparation of amine. Structure of thalamide, it is like this. See, this is thalamide. What is this? Thalamide. It is obtained from phthalic acid. Reaction of phthalic acid with ammonia gives you thalamide. Thalamide. See, this thalamide, initially it is heated with alcoholic solution of potassium hydroxide. Thalamide, it is heated with what? Heated with alcoholic solution of potassium hydroxide. See, alcoholic solution of potassium hydroxide, it is a base. It is what? It is a base. What about hydrogen? Hydrogen present upon nitrogen. See, this hydrogen, it is acidic. Hydrogen, it is what? Acidic. Acidic means hydrogen, that hydrogen can be easily removed in the form of H plus. Acidic means H plus, correct? So hydrogen, this hydrogen can be easily removed in the presence of in the form of H plus. Why it is positively charged? See, this hydrogen, it is bonded to nitrogen, which is more electronegative. So electrons will be displaced towards what? Towards nitrogen. As a result, nitrogen, it is carrying negative charge, partial negative charge. Hydrogen, it is carrying what? Carrying positive charge. So because of the difference in electronegativity, this hydrogen can be easily removed in the form of H plus. So we have a base here, OH minus. This OH minus readily abstracts a proton, H plus. OH minus will accept a proton, that is H plus and OH minus, they will combine to form what? To form water, giving us salt. It is C double bond O, again C double bond O, NH becomes NK. NH becomes what? NH becomes NK. Now this is salt. Acid base reaction always gives salt and water. Always gives you what? Salt and water. So water has been removed. So product formed, it is potassium salt. This is potassium salt of thalamide. Potassium salt of thalamide. This is the first step. So thalamide treated with alcoholic solution of potassium hydroxide, that is a base. Acid base reaction takes place. H plus Z, OH minus, they will combine to form water. Product obtained, it is NK. NK means potassium salt of thalamide. In the next step, this potassium salt, it is heated with a suitable alkyl halide. Heated with what? Heated with a suitable alkyl halide. See, we know that alkyl halide molecule contains charge, positive charge and negative charge, or it is a polar molecule. Again, it is due to what? See, R means carbon, carbon and halogen bond here, correct? So, between carbon and halogen, halogen it is more electronegative. Electrons will be displaced towards what? Towards halogen. As a result, halogen carries partial negative charge, carbon carries partial positive charge. Because of the presence of partial positive charge, nucleophile can readily attack alkyl halide molecule. It is readily attacked by the nucleophile. So, this is alkyl halide, it is attacked by the nucleophile. Why? Because in an alkyl halide molecule there is a polarity, positive charge, partial positive charge and partial negative charge. So, nucleophile readily attacks the carbon atom, thereby halogen will be displaced. Halogen will be displaced in the form of X minus. So, here also we have one alkyl halide RH. So, here carbon carries what? Partial positive charge, halogen carries partial negative charge. Now, what about nitrogen and potassium? Nitrogen it is more electronegative. So, nitrogen it is negatively charged, potassium it is what? It is positively charged. Potassium it is what? Positively charged. Now, this one N minus, this is thalamide ion. What is this? Thalamide ion, it acts as a nucleophile. Acts as what? Acts as a nucleophile, and it readily attacks the alkyl halide. It acts as a nucleophile and thereby attacks what? Positively charged carbon. Halogen will be displaced and this halogen X minus combines with K plus forming Kx. Forming what? Forming Kx. Okay, I can write the product here. Here it is C double bond O. Again it is C double bond O. Initially it was NH, then it was NK. Now it is NR. What is it? NR. What is NR? We can name this compound. See, R means alkyl group. It is a substituent group present upon nitrogen. So, it is N alkyl. What is this? N alkyl. So, N alkyl thalamide. What is this product? N alkyl thalamide. So, what is the first step? Thalamide treated with alcoholic solution of potassium hydroxide. Acid base reaction takes place giving salt and water, that is potassium salt of thalamide and water. This potassium salt of thalamide, in the next step, it is heated with a suitable alkyl halide. Suitable alkyl halide. Nucleophilic substitution reaction takes place. Alkyl halides readily undergo nucleophilic substitution. So, thalamide ion, it acts as a nucleophile, readily attacks what? Positively charged carbon, thereby it forms what? N alkyl thalamide. N alkyl thalamide. Last step. See, this N alkyl thalamide, it is subjected to hydrolysis. Subjected to what? Subjected to hydrolysis. Since we are using a base, it is not an acid base, it is called as alkaline hydrolysis. We are using what? We are using alkaline hydrolysis. So, N-alkyl thalamide, in the next step, it is subjected to alkaline hydrolysis. What is hydrolysis? Decomposing a compound or breaking a compound by adding water molecule. By adding what? By adding water molecule. So, N-alkyl thalamide, it is decomposed by adding what? By adding water molecule. So, after the decomposition, we have to get what? we have to get an amine. So this compound, it is hydrolyzed by adding a base. So where does bond cleavage occurs? See, bond cleavage occurs at this position. Both the bonds will undergo cleavage. Why? Because this bond, carbon-nitrogen bond, it is a polar bond. This is also a polar bond. So nitrogen, it is more electronegative. Carbon, it is less electronegative. So bond becomes polar. That bond can be cleaved easily. So hydrolysis occurs here. So nitrogen, since it is electronegative, carries which charge? It should carry negative charge. Carbon should carry positive charge. So nitrogen carries negative charge, carbon carries positive charge. So across carbon, since it is positively charged, OH minus will be added. Plus charge minus OH. Nitrogen carries negative charge, so H plus will be added here. Understood? So this is water. We need one more molecule of water, so in order to cleave the second bond, carbon-nitrogen bond, so again H plus it is added across nitrogen, OH will be added across carbon, OH minus will be added across what? Across carbon. So bond cleavage occurs here. I think it is clear. See, carbon, it is carrying positive charge, so OH minus here. Nitrogen carries negative charge, so you have to write positive ion, H plus. Water contains what? Water contains H plus and OH minus. H plus must be added across negative ion. OH minus must be added across positive charge. Across what? Across the positive charge or positively charged atom. Okay, so this is positively charged, so OH minus. This is negatively charged, so H plus. H plus OH minus. So bond breaks here. So after the cleavage of these two bonds, what will get? See, it is RNHH, correct? It is RNHH, means it is RNH2. What is this? RNH2, that is amine, primary amine. Along with this primary amine, we'll get, here I can write, C double bond O, again it is C double bond O, OH. This is also OH. What is this? Benzene ring containing two COOH groups. It is named as phthalic acid. What is this? Phthalic acid. It is acidic. Phthalic acid, it is what? It is acidic. We are adding a base, correct? Which one? Sodium hydroxide. So formed compound, it is acidic. Reaction, it is occurring in an alkaline medium or in a basic medium. So formed acid readily reacts with the base. Again acid base reaction takes place. This acid readily loses H plus. Base liberates what? OH minus. So H plus and OH minus, they will combine to form water, and thereby will get what? After removing the water, will get ONA. Here also ONA. This is sodium salt. Sodium salt of phthalic acid, it is called as sodium phthalate. What is this? Sodium phthalate. Sodium phthalate, it is the compound obtained along with what? Along with the primary amine. See, why aromatic primary amine cannot be prepared by using this method? Aromatic amine cannot be prepared because, see, if I want to prepare aromatic amine, here in the place of RX, what I have to take? Here? I have to take aryl halide. I have to take what? Aryl halide, all haloarine. So aryl halides, they are what? They are less reactive towards nucleophilic substitution, or they are undergoing nucleophilic substitution under drastic condition. Under what? Drastic condition. So that aryl halide cannot undergo nucleophilic substitution with the nucleophile, that is thalamide ion. That is what? That is thalamide ion. So aromatic primary amine cannot be prepared by using Gabriel thalamide synthesis. Only aliphatic primary amine can be obtained by using this method. Let us write the equation once. starting compound. What is that starting compound? It is thalamide. Structure of thalamide, it is like this: C double bond O, C double bond O, NH. This is thalamide. This thalamide, it is treated with alcoholic solution of potassium hydroxide. Alcoholic solution of potassium hydroxide. Alcoholic solution of potassium hydroxide, it is what? It is a base. So hydrogen present upon nitrogen, it is acidic. So hydrogen can be removed in the form of H plus, correct? So this H plus combines with OH minus forming water. This is acid, this is a base. Here it is C double bond O. Again it is C double bond O. Now NH becomes what? NH becomes NK. NH becomes what? NK. This is potassium salt. Potassium salt of thalamide. Next step, treating it with alkyl halide. Treating it with what? With alkyl halide. So removal of potassium halide. Potassium halide will be removed. Nucleophilic substitution reaction. This is C double bond O. C double bond O. Now NK becomes, it becomes what? Becomes NR. NR. What is R? R means alkyl group, which is the substituent group present upon nitrogen. So it is named as what? N-alkyl. N-alkyl thalamide. N-alkyl thalamide. Next step. This N-alkyl thalamide, in the last step, it is subjected to alkaline hydrolysis. So it is treated with aqueous solution of sodium hydroxide. Hydrolysis takes place here. Hydrolysis means breakage of cleavage of bond, covalent bond. So here it is OH minus, H plus. Here also H plus. Here it is OH minus. We'll get a primary amine. We'll get a primary amine R NH2 along with primary amine. Actually, phthalic acid is obtained. This phthalic acid, it is acidic, reacts with the base sodium hydroxide forming a salt. So COOH becomes COONA. This is also COONA. Name of this compound is sodium. What is it? Sodium phthalate. Sodium salt of phthalic acid named as sodium phthalate. So this is very important for the examination. Gabriel thalamide synthesis. See, in organic chemistry, named reactions are very important. You have to study named reactions correctly. So it is very important for the annual exam. Gabriel thalamide synthesis. Next one, sixth one, last method. Hoffman bromide. It is Hoffman bromide degradation. Or I can also write it as reaction. Hoffman bromide reaction. or Hoffman-Bromide degradation. This is also important, named reaction only. Gabriel thalamide synthesis and Hoffman-Bromide degradation. Usually they will ask either Gabriel thalamide or Hoffman-Bromide reaction or Hoffman-Bromide degradation. See, Gabriel thalamide synthesis, it is used only for the preparation of aliphatic primary amine, whereas Hoffman-Bromide reaction, or by using Hoffman-Bromide reaction, we can prepare both aliphatic primary amine as well as aromatic primary amine. Well, let us explain this reaction, Hoffman-Bromide degradation. See, bromamide means we have to take bromine and amide, bromine and amide, bromamide. So amide, formula of amide, it is RCONH2 or it is C double bond ONH2. What is the formula of amide? It is CONH2. So it is RCONH2, acid amide, bromamide, amide I wrote, bromine. Along with the bromine, one more reagent I have to add, either sodium hydroxide or potassium hydroxide. I will take potassium hydroxide, either it can be aqueous potassium hydroxide or alcoholic potassium hydroxide, anyone you can take. So acid amide treated with bromine, acid amide treated with what? Treated with bromine along with potassium hydroxide, This potassium hydroxide can be either alcoholic or aqueous also, So this amide, it is heated. This is amide treated with bromine and potassium hydroxide, alcoholic or aqueous potassium hydroxide. See, name itself says degradation. Degradation means breaking. So during the reaction, C double bond O group, it is lost. It is what? It is lost in the form of carbonate. So CO lost in the form of what? In the form of carbonate. So carbonyl group, this group it is carbonyl group. That carbonyl group it is removed in the form of what? In the form of carbonate. So after removing carbonate, what is left out? It is RNH2. RNH2 means primary amine. What is RNH2? Primary amine. So during Hoffman-Bromide degradation, during Hoffman-Bromide degradation, migration, I can say migration. See, initially it was CONH2. Alkyl group, it was along with carbon. Now it is along with what? Along with nitrogen. It is along with what? Along with nitrogen. So during the reaction, migration of alkyl group takes place from carbonyl carbon to nitrogen. During the reaction, what happens? Movement of alkyl group takes place from carbonyl carbon to nitrogen. So CO it is removed, correct? So CO it is removed in the form of carbonate. Which carbonate? Since we are taking potassium hydroxide, it is removed in the form of potassium carbonate. It is removed in the form of what? Potassium carbonate. Potassium, it is K plus, carbonate, CO3, 2 minus, cross multiply, K2, it is K2, CO3, potassium carbonate. See, along with the potassium carbonate, we will get what? We will get potassium bromide. Since there are 2 atoms of bromine, I have to write 2 KBr here. 2 KBr, one more product, that is H2O. That is what? That is H2O. So 2K, here also 2K, totally 4. So 4 KOH. So this is 2H2O. It is what? It is 2H2O. Clear? So acid amide treated with bromine and potassium hydroxide or sodium hydroxide. We can take sodium hydroxide also. CrCONH2 treated with bromine We can take sodium hydroxide also. So CO it is removed. We'll get primary amine. Since we are using sodium, I have to write sodium carbonate. Other one it is sodium bromide. One more it is water H2O. It is 2 NaBr. 2 plus 2 it is 4, correct? This is 2 H2O. 2 H2O. We shall write one example for this. Aliphatic as well as aromatic. For example, in the place of R, I will take methyl group CH3, C double bond O, NH2. This is amide obtained from acetic acid. Amide obtained from acetic acid. Formula of acetic acid is CH3COOH. So this is CH3CO, acetic acid. Reaction of acetic acid with ammonia gives you acetamide treated with bromine and sodium hydroxide or potassium hydroxide. CO we have to remove. Remove this CO. What will get? CH3NH2. CO it is removed in the form of carbonate, that is sodium carbonate. Along with the sodium carbonate, sodium bromide and water. This is 2 NaBr, 4 NaOH, 2 H2O. This is aliphatic amine. Name of this amine it is what? It is methylamine. Methylamine. We can take aromatic also. If I want to prepare aromatic, in the place of R, I have to take benzene ring or C6H5. C6H5 CONH2. C6H5 CONH2. This is amide obtained from benzoic acid, benzamide. What is this? Benzamide treated with bromine and sodium hydroxide. This is delta heating. Remove CO. We'll get C6H5NH2. C6H5NH2. This is aniline or benzenamine. Primary amine, aromatic primary amine. Along with the amine, we'll get carbonate, sodium bromide and water H2O. This is 2 NaBr, 4 NaOH, 2 H2O. So Hoffman bromide reaction can be used to prepare both aliphatic primary amine as well as aromatic primary amine. In Hoffman bromide degradation, amide it is heated with bromine and potassium hydroxide, either alcoholic or aqueous potassium hydroxide. Migration of alkyl group takes place from carbonyl carbon to nitrogen, forming a primary amine. Very important, Hoffman bromide degradation as well as Gabriel thalamide reaction. Study both the reactions properly, Gabriel thalamide and Hoffman bromide reaction. We will continue it in the next class. Thank you.